here to present my project as a part of embedded system internship at MSc Information Technology Private Limited. The title of my project is Washing Machine Simulation using PIC16F877A microcontroller. This project was completed under the valuable guidance of my mentor S. Priya ma'am. Coming to learning outcomes from this internship, introduction to C programming language, as it is establishing the basic required for embedded system development, and microprocessor and microcontrollers, embedded system and its components. Next, PIC microcontroller, and here we have used it for the project this microcontroller only, and software requirements, peripheral description, and at last project demonstration. Coming to introduction to C programming. C is a general-purpose procedural programming language developed in the early 1970s by Dennis Ritchie at Bell Laboratories. It was designed to develop the Unix operating system and has since become one of the most widely used programming languages in the world. And these are the key features of C programming language. Due to its simplicity and efficiency, we are using. And these are the key components of C programming language. And where it is used is system software development, embedded software development, OS, kernel development, firmware, middleware, and many more. Coming to the data types in C, there are three types of data types: primary data type, derived data type, user-defined data type. And these three are the C data types. And inside this primary data type, we have integer, character, float, and void. Coming to derived data type, arrays, functions, pointers. Pointers are the and functions are the main for the C programming languages. Next, user-defined data type, structures, union, and enum. Here is about microprocessor and microcontroller, and these are the block diagrams for this. As the microprocessor and microcontroller focusing on their roles and distinctions over here. Introduction to embedded system, as it is the combination of software and hardware with some mechanical parts to perform a specific task. Categories of embedded systems are divided based on their performance and based on its complexity. Based on its performance, real-time embedded systems are standalone, network, and mobile embedded system. Coming to its complexity, we have three types: small scale, medium scale, and large scale embedded systems. Now here we have studied about the PIC microcontroller, as it is the main for this project. And here is the key features of PIC microcontroller. Software requirements, we have MPLAB X IDE, a user-friendly IDE for designing, writing, and debugging. And compiler, here we have used is MPXC compiler. And we have PICSimLab. Coming to LED, light emitting diode, as it has and these are peripheral description we have used in for this project: CLCD, character liquid crystal display, and switches, interrupts, and hardware interrupts and software interrupts, timers, as PIC16 microcontroller has timer 0, timer 1, timer 2. Coming to introduction to project implementation. Why this project? The washing machine control project was chosen because it is a practical and real-world embedded system application common used in every household, and I will show you the demonstration and gain hands-on experience with the embedded simulation tools. Project setup began by creating a new standalone project in MPLAB X IDE, selecting PIC16F877A as the target device. Here, to create a project, first select on file and create new project. Here I have already created project washing machine simulation. Click on this. Here we can see the files. I then added two type of files to organize the project entire code. First one is header files and second one is source files. These files was created to declare the functions, constants and macros used in the project. It helps to make the code modular, easier to maintain. So inside the header files, I have created see here main code, and also I have created function.h and for display here CLCD, next digital keypad, and also included timer. And the next file is source file. Here you can see this file contains the actual implementation of the program logic, including the main function and all control functions for the washing machine stages. See here. Here keeping header files and source files separate improve code readability, and this considered as the best approach. You can see here. Once the code was done, I clicked on the build project button here in MPLAB X IDE. The build completed successfully. You can see here. Here you can see. Here you can see. The build completed successfully as indicated in the output window, and the hex file was created without any errors. File. Later we have to select board. Here PICGenius. Then we have to select microcontroller PIC16F877A. Make sure and clock is 20 megahertz, and loaded it into virtual PIC16F877A microcontroller in PICSimLab. Here on display it's showing that available washing programs. Such as normal, heavy, rinse and spin. Here on LCD display is showing a press key file, powering on washing program. I select the desired washing mode. For example, when I press the key for heavy wash, the LCD updates to show heavy wash and starts the countdown timer for the program. See here on LCD display it's showing heavy, and also it's showing water level, auto, low, medium. According to our choice, we can select. LEDs on simulation board light up to indicate which operation is currently active. There are also start and stop buttons available. When I press the start button, the machine begins the selected program. See here time also showing. If I press the stop button, it pause or stop the process. See here, switch 5 and switch 6 options are showing here. This simulation clearly illustrates how the controller controls the washing machine logic and allows us to test it without any physical hardware. See here at the end of the simulation, the LCD displays a message indicating that washing cycle is complete. See here, we can remove the cloths now.